Welcome to our channel Maths Bench. Everybody first in this bench. This channel for the students who are studying 10th class or preparing for the 10th class exams. I hope you like this video. In this video I would like to discuss about the definitions and useful formulae for the exams. Okay, let's start the first one. Now the first lesson, chapter 1, real numbers. In this, the definition, real numbers, the union of rational numbers and irrational numbers are called real numbers. The real numbers are denoted by R, and the points here, Q union Q dash is equal to R. Q is rational, Q dash is irrational. Union is real number, so denoted by R. Q intersection Q dash is equal to pi, because there is no common numbers between them, and Q is subset of R. Rational is subset of real numbers, Q dash irrational numbers also subset of the real numbers. Natural numbers is subset of whole numbers, whole numbers is subset of integers, integers are subset of rational, rational numbers are subset of real numbers. This is the first slide for you. The next slide. Euclids Divisionlemma. If a comma b are any two positive integers, there exists unique pair of integers q and r satisfies the condition a is equal to bq plus r, where 0 less than or equal to r less than b. Right? Now this Euclid division lemma useful to find the HCF of the numbers. Right? And are you clear? The next slide. The fundamental theorem in arithmetic. Every composite number, the greater than 1, every composite number can be expressed as product of prime factors. Suppose if we taken 12, you can write as 2 into 6. Again 6 can be written as 2 into 2 into 3. So finally 12 we can write as 2 into 2 into 3. So here 2 and 3 are prime numbers. So any composite number can be expressed as product of prime numbers. This is a fundamental theorem in the arithmetic. Well, let's go for the next slide. Let x is equal to p by q is a rational number where is terminates when the prime factorization of q, the denominator, is in the form of 2 to the power n into 5 to the power m. Again, let x is equal to p by q is a rational number which is terminates when prime factorization of the q is in the form of 2 to the power n into 5 to the power m. Shortly, we can say in normal language, the denominator factors are 2 and 5, then it is called a terminating decimal number. And the next one, and let x is equal to p by q b is a rational such that the prime factorization of q is in the form of 2 power n into 5 power m, then x is called terminating decimal number. Converse of the previous statement. Right? If they are in the form of 2 power n into 5 power m, definitely they are terminates decimal number. Now the third one, let x is equal to p by q be a rational number such that the prime factorization of q is not in the form of 2 to the power n into 5 power m, then x is called a non-terminating recurring decimal number. The factorization of denominator is not having common factors 2, 5. Other than 2, 5 factors are there in the denominator. Such case, the fraction, the rational number gives as a non-terminating, non-recurring decimal number. Okay, let's go for the next slide. Well, these are the next slide. Now we can say sum of two rational numbers is always rational. Not only the sum, either difference of the two rational numbers is a rational, the product of two rational numbers is also a rational, and the division of two rational numbers is also rational. I mean sum or product or subtraction or division of any two rational numbers gives the same type of numbers, I mean rational numbers. But in the case of irrational numbers, sum of two irrational numbers is need not be a rational, need not be a irrational. Sum of two irrational numbers is need not be a irrational number. Maybe sometimes irrational, sometimes maybe rational also you will get when sum of two irrational numbers. But in case of sum of two rational is always rational, but sum of irrational numbers may or may not rational, sometimes rational, sometimes irrational. Not only the sum, either difference of two irrational numbers are also need not be a irrational, sometimes rational, maybe sometimes irrational, depending on the numbers what you have taken. And the next statement, product of two rational irrational numbers is also need not be irrational, and also division of two irrational numbers also need not be a irrational. I mean either sum or product or difference or division of any two irrational numbers need not be a irrational. I mean sometimes rational, sometimes irrational, depending on the numbers what have taken. Using of that we can get the result what type of numbers are there, either rational sometimes, sometimes irrational. Okay na? In examination questions also will give in the same type. Okay na? Product of two irrational numbers is irrational numbers. Is he correct or not? Justify your answer. Ravi said that product of two irrational numbers is always irrational number. Is he correct or not? Justify your answer. Okay now, like that they will ask the questions. We have to write no, not always product of two irrational numbers is irrational, sometimes only, need not be as irrational. That you have to write the answer. Okay, let's go for the next slide. Now the logarithm. In general, a and n are positive real numbers such that a is not equal to 1. We can define logarithm of n to the base x log n to the base a is equal to x, that implies a power x is equal to n. Let's take some examples based on this logarithm definition. 2 power 3 is equal to 8. We know it is in exponential form. This is converted into logarithmic form. Exponent value 3 is equal to logarithm of 8 to the base 2. Again 3 square is equal to 9. So here exponent value is what here? 2. So 2 is equal to logarithm of 9 to the base 3. Like that you can write anything. Suppose last one, a power x is equal to n, such that x power x is equal to logarithm of n to the base a. Right? This is the general form or logarithmic definition. And the next one, logarithm of unity with any base is 1. We know unity means 1. I mean logarithm of 1 is equal to 0. Log 1 is equal to 0 with any base. And logarithm of any number with the same base is equal to 1. I mean log a to the base a is equal to 1. Log 10 base 10 1. Log 5 base 5 1. Log x base x is equal to 1. Logarithm of any value with the same base is equal to 1. Okay, let's go for the next slide. Now laws of the logarithms, formulae of the logarithms, which are very easy, simple. Log AB is equal to log A plus log B. In terms of into, we can express as expanded log A plus log B. Next, second one, log a by b is equal to log a minus log b. And third one, log a to the power m is equal to m log a. Log a power m is equal to m log a. And next one, logarithm of 1 to any base a is equal to 0. We already discussed log 1 to the base a is equal to 0. Not only a, with any base is 0. Next, log a to the base a. Here both values are same, so result is equal to 1. And one more, a to the power log n to the base a is equal to n. If base is here a, log base also a. If both bases are equal, it gives the value as same, n is equal to n. Right? These are the formulae from the chapter 1. Let's discuss next chapter formulae. Okay? Chapter 2, sets. Cardinal property, n of a union b is equal to n of a plus n of b minus n of a intersection b. Same, n of a union b is equal to n of a minus b plus n of b minus a plus n of a intersection b. Now the third one, n of a intersection b is equal to n of a plus n of b minus n of a union b. Now Venn diagrams, we know union means you have to shade all the part, intersection means you have to shade the common part between the two sets a and b. A minus b means you have to shade only the part a and b minus a only b part. Right? Now the next chapter, polynomials. We know linear polynomial general form is ax plus b, quadratic polynomial ax square plus bx plus c, cubic polynomial general form ax cube plus bx square plus cx plus d, and biquadratic polynomial, and so on. Right? And the next slide, 0 of the polynomial. For what value the value of polynomial becomes 0, then the substituted value is called as 0 of the polynomial. Here x minus 2 is equal to 0, transpose two opposite sides, so value of x is equal to 2. So 2 is 0 of polynomial. Now if alpha comma beta are the zeros of the polynomial, then the quadratic polynomial is k into x square minus x into alpha plus alpha beta. Now sum of zeros formula, sum of zeros alpha plus beta is equal to minus coefficient of x by coefficient of x square, or minus b by a. Similarly, product of zeros alpha beta is equal to constant term by coefficient of x square, or c by a. Now alpha comma beta comma gamma are the three zeros of polynomial, then the quadratic polynomial is k into x cube plus x square into a plus b plus c plus x into ab plus bc plus ca minus abc. Next, alpha plus beta plus gamma is equal to minus gamma is equal to minus coefficient of x square by coefficient of x cube, or minus b by plus beta gamma. Next, alpha beta is equal plus beta gamma coefficient plus gamma alpha is equal to x cube, or c by a. Alpha beta gamma is equal to minus constant term by coefficient of x cube, or minus d by a. Okay. Next formulae related to these concepts. Alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. Alpha cube plus beta cube is equal to alpha plus beta whole cube minus 3 alpha beta plus alpha beta. alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. Next, alpha plus beta whole square is equal to alpha square plus beta square plus 2 alpha beta. And alpha minus beta whole square is equal to alpha square plus beta square minus 2 alpha beta. Like that, and the remaining all pause the video and memorize them. Okay, the next to content. These all formulae helps to solve the problems if we given problems based on the roots. If we ask alpha square plus beta square, or 1 by alpha plus 1 by beta, or alpha plus beta by alpha beta, if we given these type of problems, then you can use this formulae. Using of these you can solve the problems which are helpful to the solvation of polynomials, right? Let's go for the next chapter, chapter 4. Pair of equations can be classified into two types: consistent equations and inconsistent equations. Again, consistent equations can be classified into two types: independent equations and dependent equations. Right, in and overall we will get the three type of equations. One is independent equation, second one is dependent equations, and third one is inconsistent equations. Condition for the consistent equation is a1 by a2 is not equal to b1 by b2. Third one, c1 by c2 equal or not equal, that is not necessary. Simply a1 by a2 not equal to b1 by b2 is enough. Third one generally will write as not equal. And next one, dependent equations a1 by a2 equal to b1 by b2 equal to c1 by c2, all are equal, then it is called dependent equations condition. Inconsistent equations a1 by a2 equal to b1 by b2 not equal to c1 by c2, differ by their constant only. So a1 by a2 equal to b1 by b2 not equal to c1 by c2. And the graph of the independent equations, independent means one solution, so they have intersecting lines. Dependent equations are here infinite solutions, okay na? So they will get coincident lines. And third one, inconsistent equations, they have no solution, so they are parallel lines. So solutions are, independent equations solutions are one solution, dependent equations solutions are infinite solutions, inconsistent equations solutions are no solutions. Okay, next, methods to solve the pair of equations are four. One is model method, elimination method, substitution method, graphical method. We will generally not use model method, takes very lot of time and it is not convenient to solve. The remaining three we will use. So elimination method, substitution method, graphical method. According to given problem, which method is given, that method you have to follow. If we not given any one method, we have to use elimination method. Okay, these are the formula for chapter 4. Let's go for chapter 5. A quadratic polynomial ax square plus bx plus c is equal to 0, then it is called a quadratic equation. Its general form is ax square plus bx plus c is equal to 0, where a is not equal to the 0. The methods to solve the quadratic equation, four methods are there: factorization method, formula method, completing of square method, and graphical method. Out of these four, we can use any one method. In general, we will prefer factorization method, which is easy to solve the problem. The rest of the three, if is specified, then you can use the method. Right? Next. Here is the next slide. Solutions of quadratic equations are called roots of a quadratic equation. There are two solutions, so number of roots are 2 for the any quadratic equation in general. Right, and the nature of the roots of a quadratic equation is based on the discriminant of a quadratic equation. Let's see what is the discriminant and its formula. Here is the next slide about discriminant. The value of b square minus 4ac is called discriminant. Formula for the discriminant, delta is equal to b square minus 4ac. The nature of the roots is based on its discriminant. If delta value, discriminant value is greater than 0, positive value if you got the discriminant, then the roots are real and they are not equal. Positive value if you got, roots are real and not equal. If delta value is less than to the 0 ante negative, then the roots are real, not real and not equal. Less than 0, negative, so not real, not equal. If the delta value exactly equal to 0, not positive, not negative, if you got exactly 0, then the roots are real and they are equal. If equal 0, then roots are real and equal. Next slide. Now the shape of the graph and how they will be in the quadratic equations in the graph sheet. Now in the first case, b square minus 4ac is greater than 0. Then three type of graphs in generally, that will be graph. It intersects the x-axis at 2 times. In the first case, second case, third case, each time in the first one intersected at 3 cases. So it intersects at 2 times for the x-axis. So it has 2 zeros. In the case of less than 0, it does not intersect x-axis at any point. So there is no intersection point. So there is no real roots for that. If it is exactly 0, such case you can observe that is the graph for that. It intersects the x-axis at one and only one point. So that is called root. Right? Now the next one. Formula to find out the roots is equal to minus b plus or minus root b square minus 4ac by 2a. Minus b plus or minus root b square minus 4ac by 2a. Here also we can find out sum of roots and product of roots. Sum of roots formula minus b by a and product of roots is equal to c by a. Sum of roots minus b by a, product of roots c by a is a right. Next, chapter 6, progressions. Nth term or general term or last term of AP is equal to an is equal to a plus n minus 1 into d. A plus n minus 1 into d. Next slide. Sum of n terms of AP, Sn. Sum of terms if you given, how can you find out? N by 2 into 2a plus n minus 1 into d. Sn is equal to n by 2 into 2a plus n minus 1 into d, or one more formula, Sn is equal to n by 2 into a plus l. Here a means first term, l means last term. A value equal to first term, l value last term, and d value we know common difference, and n value is equal to number of terms to be added. Right? Sum of n natural numbers is equal to formula n into n plus 1 by 2. Using of this formula we can add sum of 10 natural numbers, sum of 50 natural numbers, sum of 100 natural numbers, sum of 1000 natural numbers. If we give a number, any numbers are given, we can add by using the formula sum of n natural numbers is equal to n into n plus 1 by 2. And sum of n even numbers is equal to formula n into n plus 1. Similarly, sum of n odd numbers is equal to n square. Sum of n odd numbers n square. Okay. Next, about GP. We know in GP common ratio R is equal to formula A2 by A1 or A3 by A2 and so on. Anything you can use. In general, we will use A2 by A1. The terms are in in GP, their common ratio is same. Similarly, their common ratio is same and the terms are in GP. Now, nth term or general term or last term of GP an is equal to AR power n minus 1. An is equal to AR power n minus 1. Here we have only one an term only. There is no sum of terms according to our syllabus. So no need to solve that. Only an equal to ar power n minus 1 in GP. Right? Let's go for the next chapter 7, coordinate geometry. The distance between the 2 points on x-axis is x2 minus x1, modulus of x2 minus x1. The distance between 2 points on x-axis x2 minus x1, on y-axis y2 minus y1, I mean modulus of y2 minus y1. If the points are not on x-axis, not on y-axis, means the distance between any 2 points is root x2 minus x1 whole square plus y2 minus y1 whole square under root. Distance is equal to root x2 minus x1 whole square plus y2 minus y1 whole square. And if the distance between the given point x comma y and the origin is equal to root x square plus y square. These are the 4 distances formula: modulus of x2 minus x1, modulus of y2 minus y1, root x2 minus x1 whole square plus y2 minus y1 whole square, and last one root x2 x square plus y square. 4 distances formulae. Next go for the second exercise, section formula, midpoint formula and centroid. Let's go for the next slide. The section formula: m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. This divides internally in the ratio m1 is to m2. m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. Okay, let's go for the next slide. The midpoint of the given points x1 comma y1, x2 comma y2 is equal to x1 plus x2 by 2 comma y1 plus y2 by 2. Midpoint formula: x1 plus x2 by 2, y1 plus y2 by 2. The definition of centroid is point of concurrence of medians is called centroid. Intersection point of medians is called centroid. Centroid divides the median in the ratio 2:1. Formula to find out centroid is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. Here 3 points are there, so by 3. So x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3 is formula to find out centroid of the given triangle joining the points. Okay, let's go for the next slide. Area of the triangle joining the points equal to half modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Again, area of triangle is equal to half modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. After getting your area of a triangle, if it is 0, then you can say that whatever given points are called collinear. If the area of a triangle equal to 0, then the points are collinear. If the area of triangle is not 0, then they are not collinear. Here one more point here. If area of a triangle equal to 0, then area of a triangle equal to 0, then they are collinear and they does not forms a triangle because they are collinear. We are already confirming as one collinear, so definitely they do not becomes as a forms triangle. Similarly, if area of a triangle is not equal to 0, means we are confirming as not collinear. They are not collinear, so we can say that they are the given vertices forms a triangle. So collinear and area of triangle both are opposite. If it is collinear, does not forms triangle. If it is not collinear, it forms a triangle. Right? That is the problem there. Right? Let's go for the next slide. area of a triangle by using Heron's formula. Delta is equal to root s into s minus a into s minus b into s minus c. Root s minus a, s minus b, s minus c. Here s is equal to a plus b plus c by 2. Now the slope formula. Slope of the given 2 points is equal to y2 minus y1 by x2 minus x1. Formula to find out slope, y2 minus y1 by x2 minus x1. Right? If it is given some angle by the x-axis, then slope is equal to tan theta. Slope m is equal to tan theta. Thank you for watching. Please watch again and again this video so that you can memorize easily. Please share and subscribe for more videos. Thank you. Have a nice day.